Bismillahirrahmanirrahim. In the last part, we discussed the exponential equation. Now, this is the second part of the topic, and it is about the logarithmic equations. For the logarithmic equations, we are going to use the property saying that if we have log base b of m equal to log base b of n, then m equal to n. This is what's called the one-to-one property for the logarithm. So I'm going to apply this for different type of logarithmic equations to find the value of x. For example, let's find or let's solve the logarithmic equation. Number one, if I have len of x minus 1 equal to len of 3. If we have the same basis, then these will be equal. If we have the same basis. So in the left-hand side, I have len. In the right-hand side, I have len. Len and len, so it is the same basis. Then I can say x minus 1 equal to 3. This will give me x equal to 4. So we are applying the one-to-one property of logarithm. Another one. Number 2. So what I have len, or let's say log with base 2 of x squared minus 12 equal to log with base 2 of x. Again, since we have the same basis for the logarithm, then x squared minus 12 must be equal to x. If we have the same basis, then the quantities will be the same. This means we will have x squared minus 12 equal to x. I have a quadratic equation. Can be written as x squared minus x minus 12 equal to 0. If you move it to the other side, I will have x squared minus x minus 12 is equal to 0. Now we can solve the quadratic equation by factoring or by completing the square or by the quadratic formula. If we do it by factoring, I will have x minus 4 multiplied by x plus 3 equal to 0. Then x minus 4 equal to 0 or x plus 3 equal to 0. So the first one will give me x equal to 4 and the second one is x equal to minus 3. Now I have two solutions, x equal to 4 and x equal to minus 3. I need to check, are they okay or not? If we substitute, for example, x equal to 4 in the equation, I want to check. I will use the first one, x equal to 4. Put it in the equation. In my equation, I have log 2 of x to power 2 minus 12 equal to log of x. If x equal to 4, then I will have log 2. 4 to power 2 is 16 minus 12 equal to log. Right hand side is 4. Left hand side will give me log of 4 equal to log 4, which is okay. If we replace x by 4, then x equal to 4 is a good solution, is acceptable. Now let's check the second one. I will check now the x equal to minus 3. Now if we replace x by minus 3, let's see. If x equal to minus 3, then I have log x squared will be minus 3 to power 2 minus 12. This will be log base 2 of 9 minus 12, which is equal to minus 3. But minus 3 is not in the domain of the logarithmic function. We don't have logarithm for negative numbers. This quantity must be positive. If it is negative, the logarithmic function is undefined. It means this x equal to minus 3 is rejected. We cannot take it. Because if we substitute x by minus 3, I will have negative number with logarithm which is undefined. So x minus 3 we say rejected. We cannot take it. So the solution set for this equation will be only the number 4. So again, if we have the solutions, x equal to 4, x equal to 3, I need to check both of them, put them in the original equation. And we found, and we try to check whether that it is defined or not defined. If it is not defined, then we reject that solution. Let's take one more example. Number 3. Suppose that we have log with base 2 of x plus log of x minus 4 equal to 2. Now for this one, I have 2 logarithms in the left hand side. So I need to combine them in one logarithm. The left hand side, I have to write it as a single logarithm. And using the properties of the logarithm, this is plus. It means the left hand side can be written as one logarithm. Plus means it is a product, x multiplied by x minus 4 equal to 2. Using the properties logarithm of x with base 2 plus logarithm of x minus 4 with base 2, this can be combined in one logarithm. And using the properties of logarithm, it will be x multiplied by x minus 4. We used product property of logarithms. Now I have x times x minus 4 equal to 2. All what I need now, I will convert it to exponential form. Convert to exponential form. This is base and this is power. So I can write it as x multiplied by x minus 4 equal 2 to power 2. Base to power 2. This is base. And the other 2 is power. So it is 2 to power 2. Now open the bracket and rearrange the equation. I will have x times x is x squared minus 4x equal to 4. So I have x squared minus 4x minus 4 equal to 0. Now let's solve this quadratic equation. X squared minus 4x minus 4 equal to 0. I can do it by completing the square or by quadratic formula or by factoring if we can factor it. Now by quadratic formula, which is x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. This is a equal to 1, b equal to minus 4, and c equal to minus 4. So x is equal to, b is minus 4, so I will have 4 plus or minus 16 plus 16 over 2. Then x equal to 4 plus or minus square root of 32 over 2, or it is 4 plus or minus will be 4 square root of 2 divided by 2. X equal to plus or minus 4 square root of 2 divided by 2. So either x is equal to 4 plus 4 square root of 2 divided by 2, and this is because it is positive, we can take it. 4 plus 4 square root of 2 is positive number, so this can be okay. Or the second one, 4 or x equal to minus 4 square root of 2 divided by 2. But this is negative, because minus 4 square root of 2 is greater than 4. This is negative. And since it is negative, and we have, if we go back to the solution, to the question, I have this part. This is log of x. So x cannot be a negative number. X cannot be negative. It must be a positive number. Because of this part, this solution is rejected. We cannot take it. Say rejected. So the solution set now will be only the first number. Is this one. It is 4 plus 4 square root of 2 divided by 2. So the solution set is 4 plus 4 square root of 2 divided by 2. We can take one more. Number 4. Suppose that we have log of 5x minus 1 equal 2 plus log 2x plus 1. Now again, we need to combine or to put this as single logarithm equal something on the right hand side. So we can move this logarithm to the other side. Then I will have log base 10 of 5x minus 1 equal to, or not equal, minus log of 2x plus 1 equal to 2. Now this negative sign means I have division. I can write it as one logarithm, single logarithm of 5x minus 1 divided by 2x plus 1 equal to 2. We combine the two logarithms in one, and since we have negative, then we can use the property to write it as division. Now, since we don't have base in this one, and this logarithm means the base is equal to 10. Now base means the base is equal to 10, which means that, and now this one I can write it as in the exponential form. It will be 5x minus 1 divided by 2x plus 1 equal to the base, and this is power. I can write it as 10 to power 2. So I have 5x minus 1 divided by 2x plus 1 equal to 10 to power 2. Or it is 5x minus 1 divided by 2x plus 1 equal to 100. Doing cross multiplication is over 1. I will have 5x minus 1 equal to 100 multiplied by 2x plus 1. Open the bracket. We'll have 5x minus 1 equal to 200x plus 100. Move it to the other side. I will have 5x minus 200x equal to 100 plus 1. Then it is minus 195x equal to 101. Or x will be minus 101 divided by 195. It is negative. So let's check. Can we have negative number, or we can't have that one? If we replace x by negative 100, 105, then we'll have negative number, which means this is not defined. Also, this cannot be defined with negative numbers. It means there's no solution for this one. This is also cannot be taken. This is rejected. Which means there's no solution for this problem. So this is how to find or how to solve logarithmic equations. Just write as a single logarithm and then convert it to exponential form if there is no logarithm to the other side, and solve for x.